Hello class, this is Mr. Hart. In this video I want to talk about optics and specifically a lot of the applications you can use with optics in reflection and refraction. We've talked about these ideas in class, but in this video I want to dive deeper into light and how it works once we refract it or reflect it with a mirror or a lens. And so let's jump right into it. So optics in the general sense is actually the study of light and its interactions with matter. In this case, we think of lenses and mirrors, but it could be any device or material that can transfer and bend light or do something with that light. But we're going to focus primarily on lenses and mirrors. And just as a review, just to make sure we remember, reflection is when light changes direction as it hits a barrier. Whereas refraction is when the light changes direction as it changes mediums or goes through a medium. So not surprisingly, reflection would make something bounce off, refraction makes something go through and change its angle. And then this will come up later in the videos, but something we need to keep in mind is that the angle of incidence is the angle that it enters in. So if you have a flat surface, then you want to make sure that you figure out the angle that it's coming into that surface at. Okay. We'll talk about that more when we do Snell's law, but for now, just keep that in mind as we go through these lessons. The first thing I want you to see is a cool application of reflection. So we know that with a mirror, you're going to have light bounce off and come back to you, but what if you have a mirror and a one-way mirror put together? So that's when this affinity mirror comes in. And what an affinity mirror does is it basically puts a bunch of light bulbs behind a one-way mirror, and a one-way mirror is just a regular mirror that happens to be lighted on one side, and it has a full mirror on the other side of it, and so the result is you get this big long chain of lights that occurs. But once you turn the light off, then it just goes back to being a regular mirror. And so an infinity mirror is a really cool demonstration of the power of using reflection well. We're going to move on to some other applications, and specifically with refraction. Now with refraction, you may have seen the demo where you put a pencil in water and it looks like when you put it in the water it's bending. Basically, if you put anything in water, weird things are going to happen to how it looks. But that's because as the light enters the water, it actually bends slightly, right? Whereas the light tries to escape the water, it also bends slightly in that process, which makes these weird effects. A good application of understanding this is thinking about fishing, okay? Now, maybe you have or have not gone spearfishing. I haven't particularly. But one of the first things you learn when you go spearfishing is to look at the fish and to aim below where you see it. And the reason why this is because of refraction. So as the light from the fish, where he really is, comes up to the water, it bends slightly. So as it bends, as it comes out of the water, you don't realize that bend is there, so to your eyes, it just looks like the fish is in a straight line, because that's how we're used to seeing things and thinking about things. And so you would see the fish right here, but in reality that light has bent, and so the fish is down lower than where you saw him. So this brings up a good point. If you can bend light with a mirror or a lens, then you can create what's actually called an image. And so an image is when you make something look like it's there when it's not. And so there's real images, which makes it look like it's in a particular physical location like the fish. Or there's a virtual image, which makes it look like it's in the mirror, for example. You know it's in a plane that doesn't exist, but you can still see everything in that plane. And so you see something that's there that really isn't. Okay, let's start with virtual images because those are easy to think about. But with a virtual image, basically you're bouncing light off of something, generally a mirror. And because of that bounce, it makes it look like there's something in that mirror that's not there, right? You look in the mirror, you see yourself. You know you're not inside the mirror, but because the light has bounced off that plane, suddenly it looks like that thing exists in that location. Okay, if you want to try this, try looking down at something in the mirror and it will look like it's in a straight line from where you see it. Another image is the real image, which is when you have light come through a lens and it bends. And so the light from the candle, for example, would go through this lens and bend. And so if you're looking at it over here, you might see a candle in this spot. We'll see some cool applications of that in a second. Here's another visual showing that if you see all the light coming from this candle, you'll notice it all bends together as it goes through the lens and creates that image on the other side. This is exactly how cameras work. They're trying to get a real image on the camera plane. And we'll talk about cameras again in another video. Okay, so now that we've talked about this basic idea of bending light to make it go someplace that it normally wouldn't, let's talk about some of the really cool things you can do with it. We looked at infinity mirrors, but here's another really cool one, which is called a lenticular image. So you may have seen these on baseball cards, or when I was a kid, the big one was Yu-Gi-Oh! Or Pokemon. But what a lenticular image does is as you look at it in different angles, it causes the image you see on the poster, or whatever it may be, to change. And the reason this works is because you're actually printing slight angles on the paper. It's not really even a paper, it's kind of almost this little grid of hills, and each side of the hill has a different color on it. So if you look at it from one angle, you get one image. If you look at it from another angle, you get another image. A really cool story with this is I was showing this principle to one of my students, and he had a Pokemon card that had a lenticular on it, and he had it in front of me, and I could see the image in front, but he also had some water on the table, and you could see a different image from the water that was coming up as it reflected light from one direction and then from the light directly to it. And so lenticulars are really cool. They just have different images printed on each side, and you can see the different colors from the different angles that you view it at. Okay. Another really fun one is a teleprompter. So you may have heard of these before, seen these before, but this is exactly what newscasters use, or a lot of people that give presentations or talks will use a teleprompter because it allows them to look directly at the camera. And what happens is basically what they're doing is they are bouncing light off of a one-way mirror. So it will go through in one direction but only reflect in the other. So you'll notice in this video, as I stick the camera inside, I can't see anything that bounces off of that mirror. But if I go to the other side, then I see the light coming down from the display on the bottom reflect to my eyes, and thus I can see the words that I need to speak without having it be seen in the camera. And again, it's backwards because it's reflected, so generally they'll actually flip the display backwards so you can read it the right direction. So that's another really cool use of using optics, to bounce light in one direction but not the other, so you can see it if you're the person, but you can't see it if you're the camera. Another fun one is what's called a mirroscope. And this goes back to the real images. You make something look like it's in the physical location that's actually not in. So with this one, you can see I can't grab this object because it's not actually there. It's just a set of mirrors that is shaped in such a way that it makes the light come out of that hole in just the right way to make it look like there's the object there to your eyes. And so it's really fun. You can put all sorts of things in here. You can put water, and you can try and touch it. And again, it's not really there. It's just reflected in just the right way so that it looks like you can grab it. So those are some fun demos that we can do. I want to talk about a couple other things that are just fun to think about. Another one is what we call anamorphic projection. And anamorphic projection is where you draw an image in such a way that it looks like it's in 3D space if you view it from just the right angle. So you may have seen some of these. They're really fun to do with chalk drawings and things on the road. If you look at them just right, it has this amazing 3D perspective. But if you don't draw them just right, or if you look at it from a different perspective, suddenly you have this really large flat image. But to you, if you draw it from this perspective and look at it from that perspective, it looks like a 3D object. And that's just because you're tricking your eyes again, right? You're making it look like the light is coming from a spot that normally isn't. You're not used to seeing really long, flat pancakes. So when you look at it from this perspective, your brain tricks you and makes it think it's a 3D object. This is another really fun one that I enjoy looking at. It looks like there's just random lines drawn across this image, but this isn't just someone messing up in Photoshop. This is actually what you see if you look at this street from this view. But if you suddenly change the direction that you're looking at it from, now you can see all these big red lines are in the certain spots to make it look like this from your view if you're in that spot. A couple more just for fun. This one makes it look like there's tape kind of blocking off this hallway, but you go from a different view, you suddenly see all the blue lines that were drawn to make it work. And the last one, which is my favorite, there's actually a bridge in Frederick, Maryland, where it makes it look like these statues are kind of sitting outside of the wall. But as soon as you look at them flat on, you see that they're all stretched and elongated. And the sad thing is there's actually one of a bird bath, and they've actually had some problems with some birds flying into this painting because they think that there's actually a bird bath in this spot. But it's just brick painted well. So a lot of fun applications of optics. And again, the whole idea is if you can get the light to move in the direction you want it to, you can do all sorts of cool things with illusions, and it just makes for some fun applications. So I hope you enjoyed this. Let me know if you have any questions, and thank you for watching.